Wait. I thought nothing could move faster than light. So how is it that astronomers have discovered entire galaxies zooming away from us at speeds 5, 10, even hundreds of times faster than light itself? Did Einstein get it wrong? Are we seeing a glitch in reality? Or is the universe playing by rules that most of us have never even imagined? Welcome to Histography, where we uncover the cosmic mysteries that bend the boundaries of what we think is possible. And today, we're diving into one of the most mind-bending questions in all of astrophysics. How can galaxies be moving faster than light, without breaking the laws of physics? To understand this cosmic puzzle, we need to take a journey, not just across space, but through time. Let's rewind the clock about 13.8 billion years. That's when the universe began with the Big Bang. But contrary to what the name suggests, the Big Bang wasn't an explosion in space. It was an expansion of space itself. Imagine a loaf of raisin bread baking in the oven. The dough rises, and as it does, the raisins, which represent galaxies, move away from each other. The raisins aren't moving on their own. The dough is expanding, carrying them along for the ride. That's our universe. The galaxies aren't flying through space like bullets. The space between them is stretching. And here's the wild part. There's no speed limit to how fast space itself can expand. You've probably heard of Einstein's cosmic speed limit, the speed of light. It's the ultimate rule of the universe, right? Nothing can travel through space faster than 186,000 miles per second. But, and this is important, that rule applies to things moving through space. It doesn't apply to space itself. So when we say galaxies are receding from us faster than light, they're not breaking the speed limit. They're passengers on an expanding highway, and the highway is speeding up. Still confused? That's okay. Let's paint a visual. Picture dots on a balloon. As you inflate the balloon, the dots move farther apart. Now imagine if you could expand the balloon really fast. So fast that two dots on opposite sides of the balloon are separating at speeds greater than light. The dots didn't do anything. They're just sitting there. But the surface between them grew so quickly that it pushed them apart faster than light could travel. That's what's happening with distant galaxies. The farther away a galaxy is, the faster it seems to be moving away from us, not because it's racing through space, but because more and more space is stretching between us. And this isn't just a theoretical idea. It's something we've actually measured. Back in the 1920s, astronomer Edwin Hubble observed that galaxies farther from Earth were redshifted, meaning the light coming from them was stretched toward the red end of the spectrum. That redshift meant they were moving away. And the farther they were, the faster they moved. This discovery changed everything. It led to what we now call Hubble's law: velocity equals distance times a constant. The more distant a galaxy is, the faster it recedes. Simple, right? But when you plug in large distances, say, billions of light years, something strange happens. The numbers suggest galaxies can recede at speeds greater than light. At first, that seems impossible. But now you know, it's not the galaxy that's speeding, it's the space in between that's doing the stretching. This cosmic expansion has real consequences. It means there are galaxies out there that we'll never see, not because they're hidden, but because the light they emit today will never reach us. Space is expanding so quickly that their light is being pushed away faster than it can travel toward us. That creates a kind of cosmic horizon, a limit to how far we can see. Beyond that lies the unobservable universe, a vast realm of stars, galaxies, and maybe even civilizations, forever out of reach. And here's the kicker: the expansion of the universe isn't slowing down. It's speeding up. In 1998, two teams of astronomers discovered something that shocked the scientific world. Distant supernovae were dimmer than expected. That meant they were farther away than they should be. Which meant the universe wasn't just expanding, it was accelerating. Something was pushing the cosmos apart faster and faster, a mysterious force we now call dark energy. We don't know what dark energy is. We just know it exists, and that it makes up nearly 70% of the entire universe. It's everywhere. in every cubic centimeter of space. And as space grows, so does the amount of dark energy. It's like a repelling pressure that keeps increasing with time. This explains why galaxies are moving away from us faster than light, and why the number of unreachable galaxies is growing every second. Think about that for a moment. Every time you blink, galaxies disappear from our observable universe, slipping beyond a point where their light can ever reach us. It's like the lights of a distant ship sinking below the horizon, except the horizon is moving away faster than the ship could ever sail. So, does this mean those galaxies are gone forever? Not exactly. They're still out there, doing their thing. But from our perspective, it's as if they've fallen off the edge of the map. This expanding universe changes how we see everything, including our future. If this acceleration continues, and all evidence suggests it will, we're heading into what's called the cosmic isolation era. Billions of years from now, distant galaxies will become invisible. Even nearby galaxies will fade. Eventually, only the local group, our own galactic neighborhood, will remain in view. Future civilizations might look up and see only one galaxy in the sky. They might assume the universe is small, static, and eternal, just as we once did. And without evidence of expansion, without the glow of distant galaxies, they may never know the truth. They may never know how vast the cosmos truly was. So what does this all mean for our understanding of space, time, and the future of the cosmos? Let's imagine this. You're watching a distant galaxy, let's say, 13 billion light-years away. Because of the ever-accelerating expansion of the universe, that galaxy is now so far away that no signal, no matter how fast or how bright, can ever reach us again. It's as if the galaxy is being pulled into a cosmic fog, slipping over the edge of our observable universe. From our point of view, it fades, not because it runs out of light, but because the space between us is stretching faster than its light can travel. And here's the incredible part: this process is happening all the time. Every second, more and more galaxies are crossing that invisible boundary. Scientists call it the cosmic event horizon. And it's not just a poetic name. It's a real, physical limit to what we can ever observe or interact with. Entire regions of the universe are vanishing from our reach, not by disappearing, but by receding faster than light due to the fabric of space itself. But if galaxies are moving away faster than light, does that mean we'll eventually be alone in a dark universe? Well, in a way, yes. If the universe keeps expanding at this rate, or accelerates even more, there may come a time when only our local group of galaxies remains visible. All other galaxies, even those we can see today, will become unreachable. The night sky could go dark, not because the stars went out, but because they've become invisible, lost behind a veil of expanding space. This paints a picture of the universe that's not just vast but profoundly lonely. It's like standing on a ship in the middle of an ocean that's growing wider every second, watching the lights of other ships drift beyond the horizon one by one, knowing you'll never see them again. That's what the cosmic expansion is doing to the galaxies around us. Now, let's address the elephant in the room. Doesn't this break Einstein's rule that nothing can travel faster than the speed of light? The key is that galaxies aren't flying through space faster than light. They're being carried away by the stretching of space itself. It's the expansion of space that has no speed limit. That's the loophole that makes this possible. Einstein's laws still apply locally, where space is flat and calm. But over cosmic distances, space itself behaves in strange and astonishing ways. To make it more relatable, think of baking a raisin bread. As the dough rises, the raisins, which represent galaxies, don't move on their own. They're just along for the ride. But the dough between them is stretching. From any raisin's perspective, all other raisins are moving away, and the farther away they are, the faster they seem to move. This is exactly how galaxies behave in our universe. It's not that they're speeding away like rockets, it's that the dough of space is expanding. Now here's where it gets really wild. Some galaxies are not only receding faster than light, they always have been. That's right, there are regions of the universe that have never been visible to us, and never will be. They're born beyond our cosmic horizon, and no matter how long we wait, their light will never reach us. These parts of the universe exist in a permanent state of inaccessibility. It's like living in a bubble of light surrounded by an infinite night. But despite this vast isolation, there's a silver lining. Even in this expanding cosmos, we've been able to learn so much about the universe's origins, its structure, and its likely fate. We've detected faint whispers from the Big Bang, the cosmic microwave background, and we've mapped the large-scale structure of galaxies like a cosmic web stretching across billions of light years. And here's something even more exciting. By studying the rate at which galaxies are moving away, astronomers have been able to measure the expansion rate of the universe, what we call the Hubble constant. This tells us not only how fast the universe is growing, but also clues us into its age and ultimate destiny. But this too comes with a mystery. Recent measurements of the Hubble constant don't all agree. Data from the early universe, like the cosmic microwave background, suggests one value. But measurements of nearby galaxies suggest another. This discrepancy has left scientists scratching their heads. Is there something about the fabric of space that we don't yet understand? Could dark energy be changing over time? Or is there an entirely new force or particle at work? It's these unanswered questions that keep space scientists up at night. And they're the same ones that make the universe so endlessly fascinating. Imagine this, a universe so vast and strange that parts of it are forever unreachable. A cosmos where galaxies vanish not in flames, but in silence. A universe that grows colder, darker, and more isolated with time, and yet still brims with secrets waiting to be uncovered. So next time you look up at the stars, remember, you're not just looking across space. You're looking across time. Some of that starlight left its galaxy billions of years ago, long before Earth even existed. And because of the universe's constant expansion, that light may be the only message from its home that we'll ever receive. We're passengers in a universe that's growing faster than light, riding a wave of space that stretches out in all directions. The more we study it, the more we realize how much remains hidden, and how lucky we are to witness even a tiny sliver of it. And that, perhaps, is the most beautiful part of all. The universe is not only bigger than we imagined, it's bigger than we can imagine. If you found this exploration mind-blowing, make sure to like the video, subscribe to the channel, and share your thoughts in the comments. There's a lot more to uncover out there, and we'll be right here to dive into it with you, one mystery at a time. Thanks for watching, and stay curious.